A tetrahedral die is numbered 1 to 4. We know that the probability for each number n is equal to k over 2n, where k is a constant. We want to find, firstly, the value of k. We have the probability function here, and we can see that the die is numbered from 1 to 4. So we can calculate each of the probabilities in terms of k. The probability of getting a 1 on the die must be equal to k divided by 2 times 1, which is 2. The probability of getting a 2 is k over 2 times 2, which is 4. The probability of getting a 3 is k over 2 times 3, which is 6. And finally, the probability of getting a 4 is k over 2 times 4, which is 8. We know that for a probability distribution, that if we add all of the probabilities together, we must get 1. In other words, if we add k over 2 to k over 4 to k over 6 to k over 8, all of the probabilities must come to 1. We can put this over a common denominator of 48. We get 24k plus 12k plus 8k plus 6k. And this must be equal to 1. This gives 50k over 48 is equal to 1, and therefore k must have the value 48 over 50. We now want to write down the distribution, so we know that n can take the values 1, 2, 3, and 4. We want to write down the probability that n equals n to complete the distribution. If n is 1, the probability is k over 2. We found k was 48 over 50, so 48 over 50 divided by 2 is 24 over 50. Here we found k over 4, so 48 over 50 divided by 4 is 12 over 50. For n equals 3, the probability was k divided by 6. 48 over 50 divided by 6 is 8 over 50. And finally, for 4, the probability is k over 8. 48 over 50 divided by 8 is 6 over 50.